Here we have a pictorial representation of real numbers. N represents the set of natural numbers. W represents the set of whole numbers. Z represents the set of integers. Q represents the set of rational numbers. Q prime represents the set of irrational numbers. And R represents the set of real numbers. So the circle represents their boundaries. The circles represents their boundaries. Alright, so the information which we can gather from this diagram is that the set of natural numbers is a subset of the set of whole numbers. So what do we mean by subset? Let me give you a brief example. We know that the set of whole numbers includes 0, 1, 2, 3, 4, 5, 6, and we can continue forever. The set of natural numbers begins at 1, 2, 3, 4, 5, 6, and it goes on forever to infinity. So we can say that the set of natural numbers is a subset of whole numbers. So showing this, we can show this by simply look within the set of whole numbers. We can see we have 1, 2, 3, 4, 5, 6. It starts at 1. So we can get the set of natural numbers from the set of whole numbers. Therefore, we can say the set of natural numbers is a subset of whole numbers. So we can also say that natural numbers, the set of natural numbers and whole numbers are subsets of the set of integers. Natural numbers, whole numbers, integers, natural numbers, whole numbers, and integers are also, we can say that they are subsets of rational numbers. So they are a subset of rational numbers. Natural numbers, whole numbers, integers, rational numbers, all of these numbers are subsets of the set of real numbers. It might sound a bit confusing, but it's simple once you get the understanding. I'll explain it further. For the set of irrational numbers represented by Q prime, it is not a subset of any of these types of numbers. It is only a subset of real numbers. Good. So let's take, for example, the number 2. 2 is a natural number. 2 is also a whole number. 2 is also an integer. It is a positive integer. 2 is also a rational number because it can be written in the form p over q, where p and q are both integers. So 2 can be written as 2 over 1, 2 over 3, 2 over 4, 2 over 7, etc. 2, the number 2 is also a real number. Alright, so let's take for example 0. 0 is not a natural number, but 0 is a whole number. So the number 0 or the digit 0 can fall under the set of integers, and it can also fall under the set of rational numbers and also the set of real numbers, but it cannot fall within the set of natural numbers. So that's why these boundaries are important. Let me give you another example. For the set of integers, negative 3, let's use negative 3. Negative 3 is not a whole number, and negative 3 is also not a natural number. Negative 3 is an integer. So hence the boundaries here. Some of the numbers within the set of integers are not whole numbers. One of the numbers within the set of whole numbers is not natural numbers. So hence the boundaries here. So negative 3 is an integer. Yes, it is an integer. It is also a rational number because negative 3 can also be written in the form p over q, where p and q are both integers. So negative 3 can be written as negative 3 over 2, negative 3 over 4, negative 3 over 6, and the list goes on. For q prime, however, q prime, which represents irrational numbers, this is only a subset of real numbers. So a natural number cannot be an irrational number. A whole number cannot be an irrational number. An integer cannot be an irrational number. Rational numbers cannot be irrational numbers. However, the set of real numbers does contain the set of irrational numbers. So all irrational numbers are real numbers. So let's say we had surd 5, or the square root of 5. The square root of 5 is an irrational number. The square root of 5, it is not a natural number, it is not a whole number, it is not an integer, it is not a rational number, but it is a real number. Hence why the set of irrational numbers falls within the boundary of the set of real numbers.